Hello and welcome back to this course on programming in Rust. So in this video we're going to take a look at closures and iterators. These are two features that you're going to end up using constantly, and they're the more functional side of the Rust language. Now here's the thing about them. Once they click, they're going to change how you pretty much write everything. The basic idea is that they let you take some data and push it through a few small steps to reshape it, and your code stays clean and easy to follow. There's no speed cost either, but we'll get to that later. And this video is going to set us up really nicely for our next episode or our next project, where we're going to build a little command line tool. So here's the plan. We're going to start with closures, which are little functions that you can write inline with no name. Then we'll take you through the 3 flavors of closure. Then we'll take a look at iterators, what they really are and how they work under the hood. And then we'll play with the adapter methods like map and filter, and the consumers that finish a chain like collect and sum. Then to wrap up, we're going to see why all of this costs us basically nothing when it comes to runtime. So I've got a new project, iterators and closures, and this will be on branch lesson 12, iterators closures. So this code that we're going to write in this lesson will be up on GitHub. And we're going to first take a look at closures. So a closure is just a function without a name. You write one inline in the middle of your code. And the special thing about it, the thing that makes it a closure and not an ordinary function, is that it can reach out and use variables from the code around it. So let me delete this print line statement here, and we're just going to write the following. Okay, let me open up the terminal. I'm going to cd into the project. Just clear that, and we're going to run it. And we should see 30 being printed out. So let me get out of the terminal. Okay, so you see these 2 vertical bars, the pipes? That's where our parameters go. So this closure takes one parameter called x. And notice how we never wrote down a type for x or even a return type either. With closures, you usually don't have to. Essentially what happens is the compiler will look at how you use them and work out the type for you. And here's the closure part. So it reaches out, grabs multiplier from our surrounding code, and uses it right here in the body of the closure. A normal function couldn't do that. It could only see what you pass into it. We've stored this closure into a variable called triple, and then we've called it just like a function here. And you can also hand a closure straight to another function, and passing little bits of behavior around like that is exactly what makes iterators so flexible in a minute. So closures come in 3 kinds, and which kind you get depends on how the closure uses the things it captures. Now the good news up front, you almost never have to write these names yourself. The compiler will work it out for you. But it does really help to recognize them, because you'll bump into them in other people's function signatures. So let's write, we'll get rid of this with a comment, or a block comment. And let's write a small program with all 3 side by side. Okay, let me open up the terminal again. And we're going to write cargo run. So here we go. Okay, so 3 of them. The first one we're going to take a look at, just get rid of that, is this function. So a function closure only reads what happened, it captured, sorry. So like show here. You can call it again and again and nothing will change. So you see these empty pipes that we're calling on this show variable? The 2 bars with nothing between them, that just means that it takes no parameters. The second one is function mutable. This one changes what it captured. If you probably guessed that from the mutable signature that we've got here. So like add, essentially it's going to keep adding onto the total every time we call it. So if I open up my terminal again, I can see that that total count is 7 because we added 3, then we added 4. 3 plus 4 is 7. And that's why the closure itself has to be mutable, because again, we are changing a value. And then this function once, this one takes ownership of something it captured and moves it out, like consume. So see that move keyword here, sitting in front of our empty bar parameters? That's us telling the closure to take the own string with it, to own it rather than just borrowing it. So consume hands that string straight back. And because it's given the value away, it can only run the once. Remember, you're not choosing between these by hand. Rust is actually picking the right one for you. They only really matter when you're reading a function that spells out which kind of closure it wants. Okay, now let's take a look at iterators. So an iterator is anything that can hand you a sequence of values one at a time through a method called next. And here's a nice surprise. Those for loops that you already know how to use, they're essentially running an iterator under the hood, calling next for you on every pass. So let's do it by hand for once. We're going to take a vector, ask it for an iterator, and then call next ourselves a few times just to watch what comes out. So again, I'm just going to take that comment, end of the block comment, and we're going to write the following. All right, let me open up a terminal, go back into this original one, and cargo run. So there we go. So each call to next hands back the next value, and it comes wrapped in sum because there might not be a value at all. And that's exactly why we wrote let's mute it. Every call to the next nudges the iterator forward to the next position, so the iterator has to be mutable. Then, once the vector runs dry, it's just, I'll open up my terminal again, return none, and every time after that. So that sum or none is the option type that we've looked at from earlier. And here's the other big idea, the one that we're about to lean on. So iterators are lazy. They do no work at all, none, until something actually asks them for a value. So that laziness is exactly what makes iterator chains so powerful. And there are two kinds here. There are adapters, like map and filter. They take one iterator and then give you back a new one with a step added on, but they still do no actual work yet. And then we have a consumer at the very end, like collect or sum. And this is the thing that finally kicks it all into gear and produces a result. So I'll just extract that end block quote, or comment, sorry, and we're going to write the following. Okay, let me open up the terminal. Just going to clear this and then cargo run. And here's our output. So the total 220, and then A and B have been capitalized. So I'll just close the terminal for now and let's take a look at this. So we can read this first chain almost like a plain English sentence. So that 1 to 10 at the start is an inclusive range. So the number's 1 right up till 10. And the equal sign, again, remember, that's what makes it include the value 10. Then we keep only the even ones, and this is what this n modulus 2 is checking. So does the number divide by 2 with nothing left over? Then map will square each of those values, and then the sum will add it all up. So that's 4 plus 16 plus 36 plus 64 plus 100, which comes to 220. And notice that filter and map each take a closure. So we're all taking a closure in here. And that little inline function is exactly why we did the closures first. Now, the one thing that trips up almost everyone at the start. So see how we wrote this total, let total I32, and let names as a vector of string with the type spelled out. This part isn't optional here. So consumers like collect and sum can build lots of different types, so you actually have to tell Rust which one you want to use. And it uses that annotation to work backwards and produce the right thing. If you leave the type off, the compiler will stop and ask you for it. So this second chain ends with collect, which gathers up everything that the iterator has produced into a collection. And because we asked for a vector of string, we get a vector of uppercase string. So I'll open up the terminal again. So A and B have just been capitalized. So the model to hold on to is simple. You stack up your steps with adapters, and nothing actually happens until a consumer at the end runs it. Okay, now let's take a look at zero cost abstraction. And I've generated a bit of a diagram here because this is a part that really matters, especially in a systems language like Rust. This whole iterator chain with all its maps, filters, etc. essentially compiles down to basically the same type of machine code as a loop you'd write by hand. No extra memory allocated, no overhead from all of those methods calls. The compiler will just optimize them in a cleaner way. So you don't have to choose between the code that's easy to read and the code that's fast. With iterators, you get both at once. And that's what people mean when we talk about a zero cost abstraction. Essentially a nicer way to write something that costs you nothing at runtime. And that's a big reason why people actually use iterator chains in Rust instead of hand rolling a loop themselves. Okay, so let's wrap up, because once the idea of iterators and closures click, they really do change the way you write Rust. So let's start with closures. Essentially, a closure is an inline function that remembers its surroundings. You write a small, unnamed function right where you need it, and it can grab variables from the code around it. There are three different kinds of closure. A function just reads what it captured, a function mutable will change it, and a function once uses it up. Rust will pick the right one for you, so you don't have to make that decision. Rust will do it for you. Iterators are lazy. They hand you one value at a time through next and do no work until something asks to do work. That's what makes long chains very cheap to run. Adapters transform and consumers finish. So map and filter, add a step and hand back a new iterator. Collect or sum are what actually run the chain, and nothing will happen until the consumer runs. And chains are as fast as a loop. The compiler turns your iterator chain into the same machine code as a handwritten loop, so it's readable and fast at the same time. And this is what we refer to as zero cost abstraction. So that wraps up this video on iterators and closures in Rust. In our next video, we're going to build our next project, a command line tool, where we're going to put these iterators to work straight away. If you like this video, give it a like. Don't forget to subscribe to the channel if you want to see more videos on Rust. If you have any questions, pop them in the comments section below, and remember that the code for this lesson and other resources, really valuable resources, are going to be in the video description. Thank you so much for joining, and we'll see you in the next one.